Hello everyone. We are on another Thursday seminar, and today we have a special guest. Is someone who is working close by to the University of Campinas at a very big company that I know all of you know, probably have used their products. I'm very happy to learn more about this very relevant topic of edge, and more specifically, the computer vision applications that are changing how products are being manufactured, built. So I can anticipate probably detection of things that are not going as expected, doing some quality assessments that usually were done by humans, and now computing algorithms and artificial intelligence at these edge computing facilities at industries are shaping the fabrics. I was interacting with Rogerio. Rogerio Pedral has studied here nearby. I know that you have also some past and some present with University of Campinas, right? Your son is one of our undergrad students, and Rogerio, as usually, I don't read your biographies. If folks want to reach you, here is the contact address. And please, thank you for being here today. Feel free, and looking forward to talk more to you in around 35 minutes. I will be collecting the questions from our students that they have done their homework, and I know they have very interesting questions for you.
Yeah, that's great. So, Professor, first of all, thank you very much for the invitation. And I also thank you, Jose Wagner, Carlos Ito, and the team from Dell that also invited me to participate of this seminar. I think it's very important in order to share and exchange this kind of knowledge. Okay. So I'm going to start to share my screen here. Just 1 second. Let me swap to presentation mode.
Great. Yeah,
Please. Great. Okay.
perfect.
Okay. So, Tim, again, thank you very much for everybody that is participating of this seminar. So, my name is Rogerio Pedral. I'm a senior principal engineer here at Dell Technologies in Hortolândia. I'm based in Brazil, Hortolândia. So, I have more than 25 years of experience in manufacturing companies. So I started a long time ago working in this kind of technology company. My background is mainly a developer. So I started developing. I love that, although I'm not practicing anymore as a professional, but at home, for example, as hobby, I usually to continuing to develop something. But of course, now I have a big team here that do all of this kind of work for me. So I'm responsible to supervise them, to manage them, in order to develop this kind of technology here in Brazil. Okay, not only for the factory, but also for the customers, for the Dell customers. So we developed, tested here, and you implement in a lot of the customers this kind of technology. Okay. So, Tim, today I'm going to talk about the edge computing, to talk about the artificial intelligence, and also to talk about computer vision. How these three big technology combined can bring us a lot of insights, a lot of benefits, in order to produce more with low cost, with high quality, okay, of your product. As Professor Christian said, so you can send in the questions if you have, and by the end of this presentation, I can try to answer most of them. If the question is more technical, I can ask my team later to answer, but if I can answer the most of them, that would be great. Okay. This is the topics that I'm going to talk today. The opportunity to innovate with the data at the edge. Okay. So a lot of people, a lot of companies is talk about edge computing, but what is edge? Why AI at edge? And what is the key challenge to address that? What is the key challenge to implement edge computing, artificial intelligence in a factory like that? In a manufacturing in general, in the hospital, for example, in the cities. So what is the challenge to implement this kind of technology? And also the AI insights and the infrastructure. So what kind of infrastructure do you need in order to implement edge computing? Okay? To process a lot of data, a big amount of data at the edge, okay? And the database and the operation and the optimization, okay? So where we put those data, okay? And also the last one is the computer vision at the edge, okay? The strategy, the architecture, and also some use cases, okay? Before we started the conversation here, I was talking with the professor Christian, and I mentioned to him that it's not possible to show the project that we implemented here due to the confidentiality. Okay, but the team, everybody is invited here to visit the factory. Okay, and to see how the products are made here, what kind of technology we are implementing here in order to have a very high quality and high efficiency of your manufacturing process. Okay, of course, Professor, feel free to schedule some time to come here with the students. Okay. Okay. So then, what is edge? So I think most of you probably already know about that. They have heard sometime about the edge computing. Okay. So basically, we have the physical world, we have the digital world. So this is the combination of both. Okay. So edge computing is where the data is generated. So we can process the data, collect the data very closely where the data is generated. We have devices. I'm going to explain later in the next slides. These kind of devices that connected to the IoT devices to collect the data. Okay, and we have a huge amount of data because the number of IoT devices is increasing a lot, and the devices that has intelligence, and we could collect data from those devices. It's increasing a lot. So we are going to implement a lot of IoT or intelligent IoT devices here on the factory as well. So we needed this power of processing, of compute, in order to collect all the data and process in real time. Okay. Some examples is the mobile based station, the vehicle, the shopping, the wearable, machines on the manufacturing as well. So cameras. We are going to talk about cameras, the computer vision. So we have a lot of devices where we can collect the data, process the data, and see a lot of opportunities with those data. Okay, this intersection, okay, uh, so Edge is driving a new and exciting layer of capacity around the global scale of interaction of events. Okay, as I said, so we have a lot of devices. Okay, uh, where we can collect the data, but also we have on the other side IT, IT technology. Okay, where we have the system, where we have the computer itself that is supported by IT. And you can see we have the OT environment and you have the IT environment. Okay, and in the middle we have the edge. Why? Because we collect the data from the devices, we collect the data from the IT systems, like the system that control the manufacturing, for example, like the system that control the demand, for example, the production plan, for example. So we combine both. We process and we provide a lot of the information. Okay, and also we have the process, we have the technology, and we have, especially this one, is people. Okay, we have the people also in middle of everything. Okay, and the edge is responsible to combine these environments. Okay, so market drivers, data at the edge is growing faster than the available bandwidth. So the number of devices is increasing, for example, and we still have the cable, for example. We still have the Wi-Fi. So now we need to go beyond of that. So we need to have 5G, for example, in order to have a big bandwidth to process this amount of data. We have a lot of devices, for example, AR, VR, for example, that demand a lot of bandwidth in order to process in real time. Also the cameras. So I'm going to explain later. Okay. The traditional data centralization topology are become more problematic and overloaded. So for those that it's my age, for example, in the past, we have the data center. So the data center collected all of the data and processed at the data center. So we can imagine the bottleneck of this computing, of this processing, in order to have the information in real time. So it become overloaded. So we need to have a very robust network in order to have the information in real time. So centralize the data in the cloud, for example, is becoming a very problem when we implement more and more IoT devices and the edge computing. Okay? And also, the enhancement in edge hardware capabilities such as GPU, VPU, or FPU, for example. So now, with NVIDIA, for example, we have a lot of devices. For example, the Jetson motherboard, for example, that it's very tiny, for example, and you can implement in very places of the building, for example, to process some computer vision, for example, data. So as we put this kind of device on the network, it's almost impossible to process everything at the cloud in real time. Okay, so this is one advantage of the edge computing. Okay, and also we can distribute technology have taken the difficult out of the edge management operation. So distribute this uh, computing processing out of edge is very hard to manage and to operate. Okay, let me go to the next one. So the data worldwide. Take a look at this chart. So the amount of data is increasing day by day, with the number uh, of IoT devices. For example, the numbers of sensors, the cameras cameras, the cameras of wearables, vehicles, for example, AGVs, for example, it's increasing day by day. Okay, so the number of data is also increased because the people wants to know in real time what's the state, what's the behavior of those devices. Uh, Processing local as well, uh, and in real time. So with Edge, we can collect all of those data. You can imagine you send this amount of data to the cloud. So it's very high cost, for example. The latency is very high as well. So, we don't need to send all of this data to the cloud. So that's the reason we process the data, all of this data at the edge, and we could send it to the cloud, but only the information that we need, that is already processed at the edge. Okay, and also the latency to send all of this data to the cloud is very very high também. And of course, the security of the data. So uh, not all of the companies can send all the manufacturing data, for example, all the confidential data to the cloud because they need to protect the data. So this is another reason to keep the data at the edge because it's protected, it's inside your network, so it is protected. Uh, yes, and also the number of cases that needs real-time interaction. For example, edge AI. So we run AI at the edge. So this is another reason that we need to implement edge computing, edge infrastructure, actually, in order to process AI also at the edge. Okay. For example, some companies and some business they cannot wait 4 hours, 24 hours, for example, to receive an information to take some actions, for example, to improve the efficiency. Or if you have an issue with the quality, for example, we cannot wait so long in order to receive the feedback from the system saying that, okay, we have an issue here, please change your product, stop your line, contact the supplier, for example. We cannot wait that time. So that's the reason we process everything very locally in order to have a very quick response. Of any kind of issue. Okay. So by 2025, more than 75 of the enterprise generated data will be created and processed outside of the data center or cloud. 75. So it's a lot of data. Most part of the data will be generated and processed at the edge. Okay, one example here, why edge? So let's see where the data lives. So you see, we have the devices on the left center, and on the right side, we have the cloud or the data center, okay? So you can see the exchange of the data is very, very slow, okay? Because we depend of the topology, we depend of the network, and the cloud is not here locally. The cloud is outside of the building, okay? So you can see the latency of the data. And some companies, they have some critical process that cannot wait this kind of time, okay? So that's the reason we are implementing edge computing. Okay, so you can see the difference. The exchange of the data and information between edge device and the IoT device is very very fast. So we can process on each of these locations here and we could give the feedback for the operation very, very quick. Okay, very quick, almost in real time. We call near real time, depending of the device that you are collecting data, it's in real time. But depending of the other device where you have much more, how can I say, data, like for example, images, like cameras, for example, it's in near real time. Okay, so that's one of the main reason that you are investing a lot. Dell is investing a lot on edge computing for the customers as well. We have a lot of devices. I'm going to show you some of those devices that we offer to the customers in order to implement this kind of infrastructure. Okay, what's the main benefits in investing in edge solution? So compliance, security, as I said, productivity, increase the productivity because you can have it in real time information, cost control, availability, reliability, and scalability. So we can scale uh, the use case. You can scale the project easily. Okay, we have automation, orchestration, bandwidth, connectivity. Okay, so it's very, very fast because it's connected directly to the server, to the edge devices. The IoT devices connected directly to the IoT devices. So the response is very fast, and of course, the latency. It's one of the main benefits of edge computing. Okay? So edge investment are bring drivers by being driven by better security, productivity, efficiency, and resilience. Okay, you have IoT, IIoT, intelligence IoT everywhere, not only on manufacturing, but you have in all of the small devices. For example, we can collect the data, we can uh, send the data back to the device. So we have a lot of the opportunity to collect the data. And you can see now, today, most new data is generated at the edge. So 3 years ago, you can see it's basically half and a half generated in the process at the cloud and generated in process at the edge. Okay, but now in the next years, the trend is the edge computing and data is increasing, is more than the data being processed and collected at the cloud. Okay. Uh, I don't know if you know the difference of near edge and far edge. So near edge is the data center, okay, where we process the huge amount of data, and the far edge is the data where the IoT devices is collect the data from the IoT devices is collected in the process. We call the far edge. Near edge is the data center. Okay. So what is the opportunity? 82% of the organization says there will be a greater human and machine partnership within 5 years. So it's not because we are implementing a lot of automation AI that we will not need people. For example, people will be the key in this kind of change as well. Okay, so people will take some decisions, not only artificial intelligence will take the decision, but also people. It's in the middle of this transition. Okay, of course. Probably we already know about agent AI. Agent AI is something is incredible. So I don't know if you already heard about that, but this is something that you need to take a look, okay? Because this will change the way that we work with artificial intelligence and the data that we are collecting at the edge as well. Okay. Of course, we have the challenge. 33% of the organizations say that they can turn data into real-time insights. Okay, real time. So as I said, when you have a problem, when you have an efficiency, we know in real time where the problem is, and we can act at this problem very fast. In order to solve that, for example, in order to back the production plan uh, on the positive trend, for example, okay. So this is something that you need to real time insights uh, for the edge data. Okay, so 1 trillion of productivity gains. It's a lot of money. Okay, this is the projection of the company that implemented edge computing with AI and computer vision. So the opportunity is very, very high in order to increase the productivity, in order to reduce the cost, and also to improve the quality of the project, of the product. Okay, some use cases that we work as well, and also Dell works on that. So is security management. For example, I'm going to show some real case use cases so you can have a better idea. Predictive maintenance as well, in order to work uh, when the machine breaks, for example, when you have a problem with the machine, we can anticipate the maintenance, for example, and not wait for the machine to break. So we can do the maintenance before, okay? Because we know the behavior of the machine, and you know that with uh, this behavior, for example, we could have a problem with that machine. So before the machine stopped to work, we can anticipate the maintenance on the equipments. Okay, automated quality inspection. It's another usage of AI at the edge. So okay, we have a lot of people that inspect the machine, for example, the unit that is producing. But now with the AI, with computer vision and the process at the edge, we can do that automatically. The asset tracking and measurement. You can imagine this kind of company here. In a lot of companies, they have a lot of devices, okay? And we can track those devices and management those devices very easy using AI. And also we know what is the device that is underperforming, for example, what is the device that is stopped, and why it stopped. So we can change the route of the product, for example, if one machine is down, for example. So we can track that in real time. And also the workforce productivity. We can manage the people that you have here in order to produce the products, okay? So we can balance those people. We know exactly who is here, who is not, so we can better balance the people in order to increase the productivity of the products. Okay, let me see my time here. No, okay. Okay, so this is a data-based operation and optimization. Okay, where we have the IoT and the endpoint device, the things, we call the things, the IoT devices, okay? And we collect the data direct from those devices using the far edge devices. So we have the computers, we have servers, we have gateways that connect directly to the sensors and the actuators to collect the data, and we can process the data as well. We can have, how can I say, small AI and machine learning algorithms running at the far edge. as well. And after that, we can send those data to the near edge. Near edge is the data center. So there on the data center, we have much more compute power, uh, where you can process a lot of data, heavy computation. We have GPUs, for example, running on near edge, where we can process a lot of data, machine learning, computer vision. After that, after we process and compile all of those data, we can send the data to the cloud or to the core, okay, where the people can take a look at the data because everything is already processed. So you can imagine if you send the data from the IoT endpoint devices directly to the cloud, the core, and process everything at the core. The amount of resources, the amount of GPU, for example, to process all of the data will be very, very high. Okay, some how can I say challenge to implement, né? Edge computing, uh, not only on manufacturing, but in a lot of industrial sectors. It's not easy, especially the old ones who have a lot of companies that have a lot of years on the market. So they have legacy devices, for example, and we need to extract data from those devices. So environment and the hydrodiversity, it's a lot. So we have a lot of type of devices, for example. So it's a challenge to connect to all of those devices. And I said some legacy devices, they don't have a connection. So we need to implement some kind of connection of those devices in order to collect the data of those equipments. Okay? Operation technology workload support as well is another challenge. Distributed system operation, no local IT support. Not all the companies they have IT support. So if you have edge devices, for example, on the building, for example, so no local IT support. It's a challenge. So we need to train the people on the site in order to support this kind of implementation. Security operation support as well, and also the silos and the proliferation are some challenges to implement edge at the environment. Okay? But the moment is now, okay? We have everything on our hands. So we have the device, we have the infrastructure, we have everything here. So it's the opportunity for the companies in order to implement and to take advantage of those technology and reduce the cost, improve the efficiency, as I said. So you see on this chart here, we have some time where the innovation is triggered, where the innovation born. Okay, so we have the peak of the expectation for those technology, and after that, the not the disappointment, but when you see the result is not what we expected. So we have to mature those technologies. So we pass for this moment here. And after that, you have the plateau of the productivity. Okay, we make those technology stable. Okay, and also we have the technologies here. All of this technology, we have a time in order to uh, to 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 get those technology more easier to implement on this environment. For example, Edge AI, for example, probably will be implemented a lot in less than 2 years, for example, and also computer vision. So this will not be a technology that will take longer in order to be available to everybody to implement it here. So you can see two examples here: computer vision. and also Edge AI is a technology that is now available to everybody. Okay, and also on the right side here we have another chart that okay is saying that the edge, uh, the data that you are going to process, 52% of those data will be at the edge, and only 25% at the cloud or data center. Okay, some 5 pillars here of the technology that is coming, and that Dell is investing a lot. So legacy and the IoT convergence is one of them. Industrial IoT data translation, for example, industrial cybersecurity, which is very, very important as well. We have data and the artificial intelligence and machine learning. So we probably know more than me that we have a lot of opportunity with Gen AI, for example. But we need to store those data as well. So we have a lot of store opportunity here as well. Private mobile, 5G, 6G is coming as well. So data connectivity is very important. Connected worker, for example, everybody connected as well. AGVs, mobile robots, AR, VR, for example, is some technology that we are implementing on the market, and we need this kind of bandwidth of technology in order to support all of those devices. And of course, the sustainability and the efficiency in terms of energy. It's also very important because you can reduce the energy consumption, we can reduce the waste, we can extend the life of the equipment as well. And also, the another one that I like a lot is digital twin. We can do a lot of simulations before we implement in a real world. We can do a lot of simulations with digital twin, and also we can collect the data at the edge and in real time put on digital twin, so we can see in a virtual environment or real environment working, and where is the opportunity in order to increase the efficiency of each of those processes that you have on the industry. Okay, optimize AI for the edge. It's not an advertisement for Dell, but Dell has the best devices to implement edge computing. So, of course, we have the devices itself, the servers, the computers that run at the edge. Okay, we have the edge gateways where we collect all the data from the IoT devices with the edge gateways, and also we have the servers uh, where we are going to process all the data. Okay, so we have the servers from the data center to the data center actually, and you have the servers, the rugged ones, to be at the edge, to be at the manufacturing, for example, to be at warehouse. So this kind of servers we call rugged because they support this kind of environment without air conditioner, for example, vibration, a lot of things that is not clean as a data center, for example. This kind of rugged server can be installed on this kind of place. Okay, uh, and the people that is coming to visit the factory here, they are going to see a lot of these devices running. And also, we need to store all of this data. So Dell also has the power scale, the power store, for example, to store this amount of data. Okay, Of course, the edge devices that is running very close to the device, they don't have, it's not supposed to have this kind of amount of storage, for example. So that's the reason we need to store in a specific storage, for example, because the data is very valuable, so we cannot delete all of those data that we are capturing only because we process, because we need to store them, because we can have another AI, for example, machine learning that could take advantage of those data and also work to have another insights, for example. So that's the reason we keep the data in storage for some time. Now, the omnipresent engineer. Okay. Uh, this is the topic of my article. If anyone has the time to go to the Forbes and look for omnipresent engineer, they are going to see my article that I published, I think, 2 or 3 months ago at Forbes that explain why is the omnipresent engineer. So with computer vision, we can take advantage of that, and we can put the cameras everywhere, everywhere, not only on manufacturing, but also on retail, for example, on the hospital, on a warehouse, on a city, smart cities. We can put cameras everywhere. So everything that you can see by our eyes and take some decision because we see something, the omnipresent engineer can do the same, okay? In real time, all the time. So the engineer will be present everywhere, okay? All the time. So that's the reason I put this name, omnipresent engineer, okay? Okay, at one time or another, nearly everyone has wished they could be in two places at once. Now, with the help of advances in computer vision and artificial intelligence at the edge, engineers may be able to be everywhere at once, essentially becoming a not only present engineer, be able to monitor, analyze, and enhance industrial process from everywhere at any time. Okay, so we don't need to be on the manufacturing floor, or we don't need to be at the warehouse, for example. The cameras is there, the AI is there, so they are collecting data for us, and we can only see the information from that camera and from that AI insights. Okay, what is the four impact areas of the omnipresent engineering? Resolve issue in real time. Okay, so we don't have enough resources. For example, at Unicamp, we don't have enough security guys to be everywhere all the time. So we have cameras. So with those cameras, we can solve issue in real time. If we found something wrong, we can solve that because the system will alert the engineer that we have something wrong. Uncovering inefficiency. So, as I said, so we cannot be everywhere all the time. So sometimes we have inefficiency that we cannot see it. So, but with the cameras, we can uncover those inefficiency, enable the development of a targeted solution that enhance the process. Improve ergonomics. Okay, I think this is one of the main benefits for the people. Improve ergonomics in, real time. So we can narrate for example, the security, safety, and health team that someone is doing some movement that is not correct, and it could cause some injury for them, for example. So with the cameras, we can see that in real time and alert the team in order to fix the problem. Okay. And also enhance the operational efficiency. So remote diagnostics and the troubleshooting capabilities minimize the need of physical presence, as I said. So we don't need to be there. Uh, we can stay at the office, for example, looking for all of the information that the camera and the AI is processing for us. Okay. So start the journey from omnipresent to omniscient. Omnipresent is be everywhere. Omniscient is know everything. Okay. So we know everything. As I said, agent AI is something that you need to take a look at that is revolutionizing the industry of AI as well. Okay. So computer vision AI at the edge are revolutionizing the role of the engineering, allow them to always be virtually present everywhere. Okay. This transformation is significantly enhanced the industrial sector by not the industrial only, but also the healthcare, for example, the smart cities, enable engineers to identify inefficiency, eliminate bottlenecks, and make data-driven decision with great speed and accuracy. Okay, as the concept of the omnipresent engineer continue to evolve, companies that embrace this approach will maintain their competitive edge as manufacturing process becomes smarter and more efficient. Okay, some use cases here. Okay, that we implemented on some customers here. So we can see we have the camera. This is for security. Let me see if I need to click over here. Okay, you have the camera. We have the people with some danger area, for example. So the camera detect automatically in real time. And also we can connect those cameras to the automation. Okay, and you can stop the conveyor, for example. This is another good part of the edge because we process at the edge, and the edge device is connected to the automation. Okay, and we can stop every kind of equipment based on the information that we are collecting from the camera. And also suspicious activity alert is another use case for computer vision. Dell implemented a lot of these use cases in some customers. Okay, vehicle and the people counting is very simple. This one is very simple, but it's very important for companies that want to control the entrance and the exit of the people on the building. Also, the abandoned objects, for example, the system can detect this kind of behavior, for example. And another API or PPI equipments, for example, we can detect if the worker is wearing all the devices to protect them. Okay. And also, this is another application that we can connect with the automation. So if the employee is not wearing all the equipments, for example, the door will not be unlocked. Okay, so we keep the door locked, for example, if they need to enter in a danger place, for example. Queue management and customer experience. A lot of store, for example, is implement this kind of technology in order to reduce the queue and have a better customer experience. Okay, this is another use case for computer vision. And also in the inventory and the stock management. This is something that today in most of the companies is totally manual. But now we have the technology and the capacity to do that automatically. Okay, using only a camera and maybe a drone or a camera on the warehouse, for example, and in real time see where is the product, how many products we have on the warehouse, okay, and update the system. And also medical assistance. So the camera and the computer vision with artificial intelligence can detect this kind of behavior. Okay, this is another use case. Okay, violence, for example, another use case for computer vision. So you can see computer vision can be applied in everywhere. Everything that you can see by your eyes, as I said, we can implement AI in order to detect the same. Vandalism, for example, another use case that Dell has here implemented. And I think that's all. That's all. So uh, we have a link where I can share later with you. So we have a lot of the success stories where they'll implement this kind of use case, a lot of use cases on the real customers. So you can take a look at that. And also we have some special page from Dell. You can take a look at that and see this kind of technology as well, more details about edge computing, artificial intelligence, and what Dell is implement with this kind of technology around the world. Okay, uh, Professor, I think that's
Yeah,
all from my side.
that was great, Rogerio. Thank you a lot. I know we are a little bit behind schedule, but your videos were so interesting. And I was already thinking about our use cases with drones, flying within factories and taking videos. I think that this was really inspiring. Okay. And I love your concept of omnipresent and omni and professor, not just engineers, but sometimes I felt like I had to attend two meetings at the same time during the pandemics. Uh, and I love the abandoned object feature. That's something I would pay for because I'm a specialist and my family is a specialist of doing this type. So we would love it. So these are the notes I took. Also, the near edge versus far edge. This is something that I confess depends on the perspective, right? Because you put it from the data center perspective. It's far close to the user. I always think that my near edge is from the user perspective.
Yeah,
My first comment, and next in the few minutes I will open some more questions. So if you can comment of the near edge versus far edge, just as a starting kickoff conversation.
yeah, yeah. The far edge and the near edge. This is something that he caused some confusion for the people. I always look at the point of view that we are outside of the building. For example, the far edge is the data where the data is generated, very close to the devices, and the near edge is where the data center is. So we need to be on the point of view of the outside of the building, for example, close with the data center. Okay, so that's the difference of the far edge. The far edge is there, and the near edge is here on the data center. It's the point of view of the
Yeah,
where the data is collected.
it depends. Yeah, great. I think that was a provoking question to clarify where it comes from. This concept. Okay, so we have only 5 minutes because our students have classes at 2 p.m. But what I wanted to share with you is the type of activity that they have done. So all the students have uh, prepared some questions for you.
Mhm,
They have
mhm.
also identified good candidates of readings if they were to be prepared for an interview to work on this topic. So they have done all this homework, and from their questions, I always go through them. Some of them you have already addressed, and I always try to pick one or two that we can take in the time that we have. So. One that has come here is around energy. Uh, we know energy consumption, sustainability. Can you
Yes.
comment on some aspect where your strategies, your products take energy considerations into account from design or operational perspectives, or whatever? What would you add to this common and important, relevant question?
Yeah, this is a very good question. So at the edge, energy consumption is ours, something that you need to take a look in order when we implement this kind of new technology. Okay. When you implement edge devices, for example, of course, the edge device is a small device that consume much more energy, for example. So we don't need to invest, for example, in big data centers to process all of the data. Okay. When you have a big data center, they consume a lot of energy. Okay, because for example, we have GPUs, a lot of very powerful GPUs on the data center. But if you compare with edge devices, uh, they consume much less energy than a server on the data center. For example, the GPU that you have on the edge devices, as they run small models, small machine learning models, for example, they consume, of course, much less energy than on the data center. So that's the reason we are bringing some of those processing, removing from the data center in order to reduce the number of processing and send it to the edge, okay? Because of this difference of the energy consumed of the devices.
Yeah, that's interesting viewpoint again, because from our uh, other viewpoints, when our devices go out of energy, we want to offload like the processing power to the network and to the data center. So this is interesting. There are these trade-offs and offloading strategies that are very interesting. Let me see if we have time for. Oh, it's 2 p.m. There are so many good questions. I will share with you the spreadsheet, and we'll
Yes.
follow up. We'll visit the factory in nearby. I will bring
Mhm, mhm.
students both from grad and undergrad to learn more, and hopefully we can deep dive. Uh, um, can you just comment about again this so common question about data privacy and compliance? Is there a message that you can share that this requirement is plays an important role, or what would you comment on this one? I know it's for 30 seconds or 1 minute answer. It's impossible, but I had to put this as well.
Yeah, I think cybersecurity is a very, very critical role in order when we implement this kind of data collection. Okay, so data privacy, for example, compliance is something that we work a lot, not only with computer with cybersecurity, but also with legal, with human resources, for example, because we are collected data. For example, we have a camera on the station that we can see the operator. So they'll protect that a lot. So we cannot collect the data from the people. Okay. So this is something that we peg for a long time in order to have this kind of process implemented here. Is the privacy of the data, especially from the people, and also the sensitive data that you need to keep, as I said, inside the internal network. We cannot send this information to the cloud, for example, because we cannot have any kind of, how can I say, attack, for example, cyber security attack on this data. And that's the reason this kind of keep the data inside the edge, inside the network is very important in order to keep this privacy of the data.
Great. Yeah, I never thought about these operator concerns. Of course, they are always in the picture, and your application needs to protect them all the time.
That's correct. All
Yeah,
the time. All the
yeah.
time.
all the worker that is
That's
always there.
correct.
Yeah.
Yes.
Um, okay, Rogerio, thank you so much. We'll follow up, certainly. Thank you, everyone, for attending another seminar. Um, and as we have still 3 more seminars to go, so stay tuned for the updates on our schedule next Thursday and the follow up. And yeah, keep in touch, keep safe, and thank you, everyone.
Thank you. Thank you.
Bye bye.
Bye bye.